We're now looking at some exam questions regarding the topic of energy, the first of which is a June 2006 paper 4, question 6, which says that a block of mass 50 kilograms is pulled up a straight hill and passes through points A and B with speed 7 meters per second and 3 meters per second respectively. The distance AB is 200 meters and B is 15 meters higher than A. For the motion of the block from A to B, find, in the first question, the loss in kinetic energy of the block, and the second one, the gain in potential energy of the block. My hint to you is every time you have a question like this, in whatever part of the mechanics exam, just do a diagram. You already know this. A good diagram is half of the question right. Okay, so basically this is a ramp, and this is what you have, right? It's a simple diagram to represent A, B. This is the initial speed, this is the mass, this is the final speed. You know that it is 200 meters long. You know that this height is 15 meters. And you want to know first, what was it? It was the loss in kinetic energy of the block. And you know the loss in kinetic energy is just in this case, the change in kinetic energy. You already know that this is going to be a negative value because it is a loss. You basically just have the formula for the kinetic energy, 1/2 of mv squared, induced in these two different positions, in B and A, right? So 1/2 of mv squared minus 1/2 of mu squared. If you factorize 1/2 of m, that's just 1/2 of mv squared minus u squared. That's what you have over here, okay? Just plug in all the values that you have, and there you have it, the loss in kinetic energy, okay? Sorry, this is the change in kinetic energy, the negative value. If you are expressing the loss already contemplates the fact that it is a negative value. The loss, the magnitude of this loss is just 1000 joules. Then you want to calculate the gain in potential energy, okay? So the potential energy, you already know that's going to be increased because the height increases, all right? It's going to be a positive number. It's just mg final position minus initial. The initial will be considered 0, so it's just this height over here. So just substitute the values, and there you have it. Then, the resistance to motion of the block has magnitude 7.5 newtons. Find the work done by the pulling force acting on the block. So you have a pulling force acting on the block, which is the one that actually is responsible for the motion. You know that the resistance to motion, let's call it friction, is 7.5 newtons. So the work done by this friction is the value of that force times the distance, okay, times the cosine of the angle between the force and the displacement, which in this case is 180 degrees, all right? So the displacement is this is the direction of motion. The opposite is the direction of the force, so it is the cosine of 180, which is minus 1. The overall value is minus 1500, okay? There are two ways for you to think of this. I'm talking about looking at the sign of a particular energy or work done by a particular force. If you are completely sure that the force is draining the system in terms of energy, like this friction is removing energy from the system, you can forget about this part of the formula for the work done, okay, the cosine of the angle between the force and the displacement, and just put a minus there, all right? Just calculate the magnitude and just put a minus, okay? That's fine. If you're completely sure that the work of the force that you are calculating is taking energy out of the system, just put a minus there, all right? Or else you can just apply the formula and the minus will come as a consequence of the formula. All right, so the work done by the resultant force is the change in kinetic energy. This is the main formula for this chapter, applicable to all exercises regarding of this type, What is the work done by the resultant force? Is the work done by the force, the driving force, and the work done by the frictional force, and the work done by the gravitational force, by the weight. These are the three forces applied on the object, equals a change in kinetic energy. We also saw in lesson that the work done by the gravitational force is always the minus the change in gravitational potential energy. All right, so you can take these two routes as well. In this case, I just calculated this before, so that's minus 1,500 joules. The work done, sorry, the minus 1,500 joules was the work done by the friction. The work done by the weight is minus 7,500. Okay, I just calculated here the change in GPE, so minus that is minus 7,500 joules, all right, equals the minus 1,000 joules that we calculated before. Okay, so the only thing that you are missing is this, which is what you want. So the work done by the driving force is 8,000 joules. All right, again, did you understand the signs here? This minus over here means that this force, which is the friction, is taking energy out of the system. This minus here means that the weight is taking energy out of the system. And this minus here means that the object slowed down. Okay, this is the change in kinetic energy. You only have a negative change in kinetic energy if the object slows down. So the impact of all these forces that take energy out of the system is bigger than the impact of the force that is putting energy to the system. How do you know that? Well, the object slowed down. Okay, so that is the value. On 4. The pulling force acting on the block has constant magnitude 45 newtons and acts at an angle alpha upwards from the hill. Find the value of alpha. In my diagram, I didn't represent this. I put the force as parallel to the slope, but imagine now that the force has a certain inclination. Well, if you know the value of the force, you know that the work done by the driving force equals a force times the displacement times the cosine of the angle between those two, all right? And that's how you're going to calculate. You know this. This is 8,000. We just calculated. The force is 45. The displacement is 200. Okay, so just do cosine -1 of this result, and you have the angle. That's 27.3 degrees. June 2007, it's a paper 4, and the question is this one, 5. You have this diagram, and then you have the text that says that a lorry of mass 12,500 kilograms travels along a road that has a straight horizontal section AB and a straight inclined section BC. The length of BC is 500 meters. The speeds of the lorry at A, B, and C are 70 meters per second, 25 meters per second, and 17 meters per second respectively. All of that information is on the diagram with the exception of the mass of the lorry. The work done against the resistance to motion of the lorry as it travels from A to B is 5,000 kilojoules. So now you know the work done against the resistance to motion. Find the work done by the driving force as the lorry travels from A to B. In A to B, you don't have to worry about any change in GPE or any work done by the weight because the height is kept the same. So what we need is just to apply the main formula for this chapter. The work done by the resultant force equals a change in kinetic energy. I have here all the diagrams. The situation you are dealing with right now is this one over here. What force you have? You have the driving force and the frictional force. All right. So the work done by the driving force plus the work done by the frictional force equals a change in kinetic energy. All right. Again, you are told that the value of this frictional force, the work of that frictional force is 5,000 kilojoules. So that's 5 million joules. 5 times 10 to the power of 6. I know that this force is taking energy out of the system, so I put here automatically a minus. All right, I know this one is a positive one, as a positive impact, is providing energy. I also know that the object is speeding up, so is gaining energy. So this one is going to have a higher impact than that one. So I know that this value must be bigger in magnitude than 5 million joules, right? So I just plug in all the values and I get here this work done by the driving force. As expected, bigger than that in magnitude, right? Then, as the lorry travels from B to C, the resistance to motion is now 4,800 newtons and the work done by the driving force is 3,300 kilojoules. Find the height of C above the level of AB. Okay, so now you have change of the values and you have to worry about the change in GPE or the work done by the weight, because now you have a change in height. The formula is still the same. The work done by the resultant force equals a change in kinetic energy. So what forces you have? You have the driving force, you have the frictional force, and you have the weight. So the work done by each one of these needs to be equal to the change in kinetic energy. Don't forget, as again, that the work done by the weight is equal to minus the change in GPE. Okay. What information do I have? I have information about this, the work done by the driving force. It's given over there. I have the information given about the frictional force, not the work, but the frictional force. That's 4,800 newtons. I also know the distance. It's 500. And the work of any force is the force times the displacement times the angle between these two. And again, the angle is 180 degrees. The object goes that way. The friction has the opposite direction, so it's 180 degrees. So this is going to be -1. And the change in GPE is, did we already calculate that? No, this is what we want. Yeah, we want the height, so we're going to get the height from this. All right, this is mgh. We know m, we know g. The only thing that we do not know is h. The change in kinetic energy we can also get. This is 25, this is 17 meters per second, so everything is there. So the only thing that we are missing is the h from the formula of the GPE. Okay, you consider the height here as being 0, so the change just contemplates that height over there. Okay, so I just substituted there and I get the height. Again, in terms of the signs, you know that this, the GPE, is going to be increased as it goes up, and because of that, energy is being taken out, hence the minus over there. If you think of this in terms of, I didn't write it down, but you could have thought of this in terms of the work done by the weight, okay? In which case it will be the weight mg times the displacement, which is 500, times the angle between the I'm sorry, it will be the mg cosine of that angle, which you don't have, or sine of that angle, which you don't have, times the displacement, times the angle between the horizontal component of the weight and the displacement, which is -1, and this would give you the negative value. But it is much simpler for you in this particular case to think of this as just minus the change of GPE, okay? And the minus comes from the fact that energy is taken out of the system as it goes up, all right? And there you have the value. The h is 24 meters. Last question is from spring 2013, question paper 41. It's question, which one is it? Let me just check it. It's question 2, yeah. It says a car of mass 1,250 kilograms travels from the bottom to the top of a straight hill of length 600 meters, which is inclined at an angle of 2.5 degrees to the horizontal. The resistance to motion of the car is constant and equal to 400 newtons. The work done by the driving force is 450 kilojoules. The speed of the car at the bottom of the hill is 30 meters per second. Find the speed of the car at the top of the hill. Again, too much information in words and numbers. Much better if you have a diagram. There it is. Okay. This is the thing that you have. All the information is over here. I can retrieve everything that I need from this alone. Okay. I follow two methods over here. This is what you have over here. I can, from the information that I have, calculate this height. I know this length. I know that angle. So by use of trigonometry, I know that this is the opposite of that angle. So the height is the hypotenuse times the sine of 2.5. I have here the height already if I need it. All right. Using one of the methods, this would be calculated in another way. Now, what is happening to the car? You have a driving force, you have a frictional force, and you have the weight trying to stop it, okay, or slow it down. All right. So the formula is still the same. The work done by the resultant force equals the change in kinetic energy. This is how you're going to calculate the final speed from this change in kinetic energy. Is the only place where the speed arises in this formula. You should have everything else. The work done by the force, the driving force. Do we have it? Yes, we have here the value itself already. It's over here. The work done by the friction. We have the friction, we have the total distance traveled, right? We have the angle between them. Again, you might as well just put here the minus because you know that the friction is taking energy out of the car, all right? The technical mathematical reason why this is negative is because of this. And then you have here two options. Either you follow the expression for the work done by the horizontal component of the weight, okay, which is the horizontal component of the weight, times the distance times the cosine of these two, which is -1, and this will be a negative value, all right? Or you think of this as minus the change in GPE, okay, so minus mgh. And for that, you will need to calculate the height to begin with. This method will give you the height, all right? This one, you will need to calculate the height yourself, all right? Equals 1/2 of m. V is the thing that you want. U is 30 meters per second, all right? So I have one method or the other, okay? Don't forget this and this. They are literally the same. M is here, G is here, and sine of alpha times L is the height, as you can see over here, right? They are literally the same. It's just the concept that you follow that is different. Now it's just substituting by the values, all right? And whatever method you would use, just applying algebraic manipulation, would get the value of the velocity as being 26.7 meters per second.